let us look at vertical shifts again. Here we have a function and we add a number. So we're changing the y value. So if I look at the first example here, this is my graph y equal to x squared, my mother graph. And in this case, my red graph is the graph y equal to x squared plus 3. So what happens is at 0, I've added 3 to get to my new y-intercept. If I take this value, I've added 1, 2, 3 to get to my new point. If I look at negative 1 and I add 3, I'll get to my new point there. So each time I just added 3. So I changed the y value. So the green graph just shifted 3 units up. In this case, I've looked at the graph y equal to 2 to the x. This is my mother graph, my exponential function that goes through y equal to 1 on the y-axis. And now my new graph is y equal to 2 to the x minus 1. So my q is negative 1. So from the y-intercept of the green graph to the y-intercept of the blue graph is 1 unit down. From the point 2 there, I can move 1 down to get the point 1. And from this point here, which is not easy to read, the distance will also be 1. It will be 1 every time, even if it looks as if it's narrower. If you measure vertically down, you will only get 1 unit here. So my graph just shifted 1 unit down. So depending on the sign, if the q is negative, Q is negative, I will shift down. If Q is positive, I will shift up. I chose to write the formula as f of x minus p and not f of x plus p, so that it corresponds to all the other equations that we had before. In this case, this will cause horizontal shifts. So because my x's, what happens at P before will now happen at 0. So the graph will shift. If P is positive, it will shift P units to the right. So let us check the graphs. Here I've done again y equal to x squared, my mother graph. And if I put P equal to 2, then I have x minus 2 squared. So P is equal to 2, so it will positive, so it will shift 2 units to the right. So this is my graph y equal to x minus 2 squared, and that corresponds to my equation of a parabola, which is y equal to a x minus b squared plus q. That's why I use the x minus b and not the x plus b. If I look at my other graph, x plus 2, then I can rewrite it as x minus 2 squared. So my p is now negative. So that means I'm going to move 2 units to the left, and this will be my graph y equal to x plus 2 squared. So it seems as if it is goes in a different direction than there, but if you relate it to the formula x minus b squared, then it's much easier to remember where it goes. Otherwise, you can take values and put it in there. If I put x equal to 0, I will get 4. So at 0, I will get that value. If I put x equal to 2, I will get 0, and that will show you that it shifted right. If I put x equal to minus 2 here, I will get 0, and that will show you it shifted left. Let us look at the hyperbola again. Here we have our mother graph, y equal to 1 over x, and the red graph is now y equal to x minus 1. Okay, how can we see that? If I take a value here on this point here, I'm going to do from here to there is 1 unit. Shifted 1 unit to the right. And it also corresponds to my formula for a hyperbola, which is y equal to k over x minus b plus q. That is my formula for hyperbola. And if I now look at the blue graph, then I see I can write the x plus 1 as x minus 1. So that means because the p is negative, I'm shifting to the left. So from there to there is 1 unit, shifting 1 unit to the left. And the same will happen at the bottom. If I take a value from the green to the blue, it's 1 unit. If I take a value from there to there, it's 1 unit. So that was to the right, and this was to the left. This was to the left, and the other one was to the right. And you can, without memorizing it like a parrot, you can just take a few values, like I suggest, at minus 1, plus 1, and 0, and see what happens there. Or in this case, we can just look at when will that be 0. That is when x is equal to 1, and it will then give us a vertical asymptote at x equal to 1, whereas this one will have a vertical asymptote at x equal to minus 1, which will also help us to see how it shifted. Then for the exponential functions, y equal to 2 to the x is again our center function here, y equal to 2 to the x, and then 2 to the x minus 1 will again shift 1 unit to the right because it's minus p, which is positive. And for the blue graph, it will shift 1 unit to the left. That is 1, and that is 1. So again, we can write the x plus 1 as x minus 1. So in this case, my p is negative, so it's shifting to the left. This theme, I've written out all the explanations on the document. You can just go and check it there. But I would also suggest that if you are still not proficient with the translations, you can just go and look at each individual function, like the parabola, like hyperbola, like exponential functions, and look at vertical and horizontal shifts. It's explained well there. So this should be, it's explained very well there in my opinion.